Hello there, welcome to AWS Tech Guide session. In this session, I will show you how to create AWS EKS Cluster, means Elastic Kubernetes Service in AWS. First, I will show you how to create the cluster as well as we will create the master node. Secondly, I will show you how to install kubectl utility in your local system and connect to your newly created cluster in AWS EKS. And after that, we'll be creating worker nodes in AWS EKS. This is the complete reference course where you will get all the lab hands-on at one place. AWS CI/CD automation complete reference for production ready system. Yes, if you check that what you will learn, you will get lot more what you will expect. In this course, we have the lab or hands-on practice on code commit, code artifactory, ECS cluster, CI/CD using code pipeline, code deploy, complete hands-on practice based on actual production scenario, ECS rolling update, ECS blue-green using code deploy lab, and lot more. This is a 4.8 rated course. If you open this course, you will get this ECS blue-green deployment lab. And here I have shown every steps one by one how to set up ECS blue-green deployment. And other than this section, you will also get all these things: code commit, code guru, code artifact, ECS, ECR, code build, routing traffic, code pipeline and code deploy, ECS deployment strategies, types, and revision of this course as well. So now let's jump to our today's session. So let's proceed. Search for AWS EKS. Click on Elastic Kubernetes Service. On the left side panel, click on Cluster. Currently, I don't have any EKS cluster, so click on Create Cluster. Give a name. Select the Kubernetes version. I am selecting the latest one, which is 1.18. Now, it is asking for a cluster service role. And as you see, it is written not editable after creation. So you have to select one cluster service role. I have one cluster service role already created. That's why it is showing in the option. But let's create a new cluster service role. To do that, click on IAM console hyperlink. Open a new window. Click on create role. Scroll down and click on EKS because we are creating this role for EKS, and you will get EKS cluster, which allows access to other AWS service resources that are required to operate clusters managed by EKS. So I'm clicking on EKS cluster. Click on next. Now a cluster policy has been already added, and you can see by clicking over it, and if you read the JSON, you will find that what are the permissions it is carrying. Now click on next tag. We are not adding any tag. Click on review, give a role name. Suppose I'm just adding it AWS TG EKS cluster role. Click on create role. Now let's go back to EKS. Click on this refresh icon. Check the option and you will get the newly created cluster service role. So we are selecting AWS TG EKS cluster role. We are not selecting this encryption option for this tutorial. Not adding any tags. Click on next. Now here in the networking section, it is asking for your VPC subnets. Now At the first stage, when we are creating this cluster, we are actually creating the master node. And when you are deploying Kubernetes in your production environment, definitely your master and worker nodes should be in different VPC. But in this tutorial, to make it simple, or I can say that to use less resources or infrastructure, I'm using a single VPC to create master node as well as worker nodes. So I am using the default VPC. By default, you will see that your default VPC is selected. And if you have your custom VPC, definitely you can change it from here. But I am keeping this default VPC. And as you see, once you have selected your VPCs, it has already taken all the subnets under this VPC. So all the 6 subnets of US East 1A, 1B, 1C, 1D, 1E, 1F, all these 6 subnets it has taken as per the availability zones. Now we are not mentioning any security groups. Scroll down, and for the cluster endpoints, we are keeping it as public. But when you are implementing in your organization, in your production environment, definitely you may need to keep this endpoint access private. So based on that, you can select. For this demo, I am just selecting it as public. Now we are not changing anything for this VPC CNI version. Let it be as the latest one, which is version 1.7.5 EKS build.1. Now click on next. This is the place where you can send your audit and diagnostic logs from your Amazon EKS control plane to CloudWatch logs. So at this moment in this demo, I am not enabling anything, but definitely you can enable the scheduler, authenticator, audit, API server, all these logs. Now click on next. This is the review page before creating the cluster. Now click on create. Now it is showing one error. Cannot create cluster because US East 1E, the targeted availability zone, does not currently have sufficient capacity to support the cluster. That's fine. So go to your networking part, click on edit, and I'm just checking out the US East 1E. So under this default VPC, we have now 4 subnets. That's fine. Scroll down, click on next, next, and click on create. And it is showing creating. So it will take few minutes to show it active. So once it shows active, it means that our cluster is ready. So you can click on this refresh button and it will show you what is the status. It will take few minutes. Meanwhile, let's see how to install kubectl in local system and connect to this newly created cluster in Amazon EKS. So let's proceed for installing kubectl. This is the complete reference course where you will get all the lab hands-on at one place. AWS CI/CD automation complete reference for production ready system. Yes, if you check that what you will learn, you will get lot more what you will expect. In this course, we have the lab or hands-on practice on code commit, code artifactory, ECS cluster, CI/CD using code pipeline, code deploy, complete hands-on practice based on actual production scenario, ECS rolling update, ECS blue-green using code deploy lab, and lot more. In this session, we are going to talk about how to install kubectl in your local system and connect to your EKS cluster in AWS. Now, as we know that Kubernetes uses a command line utility called kubectl. I will share this AWS documentation link in this course. Now we will be following the instruction from this documentation. So as you see, all region except China. If you want to install kubectl on Mac OS, you have to install and follow these steps. But at this moment, will be installing in Windows system. So just I'm scrolling down. This is the steps for Linux system. And if you scroll down, you will get the steps for Windows system. So first one is open a PowerShell terminal in your Windows system. So in your Windows system, just go to your search box and type PowerShell window, and it will open a blue color, this PowerShell window. Now it's saying that download the EKS vended kubectl binary for your cluster's Kubernetes version from AWS S3. As you see, it is actually a S3 bucket from where this command will be downloading the kubectl.exe, and we will be using the Kubernetes 1.18 version only, because in our master node, when we were creating the cluster, we selected the Kubernetes version as 1.18. So I'm just copying this command, going back to the PowerShell window, pasting it over here. Let me copy it, pasting it over here, and just click on enter. It has started downloading that kubectl.exe file. It will take few minutes to download. It depends on your internet speed. Now it's showing it has downloaded. So let's go to our users directory where it has downloaded this exe file. So before going to that directory, let's go back to the instruction. So in the instruction, after download, it says that an optional step which we are not performing for now, and we are directly scrolling down to point number 4, where it's saying that the exe file which we have copied, create a new directory for your command line binaries such as c:bin. You can give any name as you want. Copy that kubectl exe which has been downloaded and edit the environment variable, the path environment variable, to point to that location. So now we have to create one directory, copy the kubectl exe and update the path variable in environment variable. So let's go and create one directory. Under my C drive, I have created one directory path and pasted this kubectl.exe which we downloaded by the script. Now I'm just copying this path. Go to Windows search, write environment variables, click on environment variables, find path variable, click on edit, click on new, add that path, click on OK, and again OK, again OK. So we have set the environment variable as well. Now let's go back to the instruction. Here it's saying that after you install kubectl, you can verify its version with the following command. So the command is kubectl version short client. So just copying this short client, and before that it's saying that close your PowerShell window terminal and open a new one to pick up the new path variable. Okay, so we are just closing this PowerShell window. Again, from the Windows search box, I am just opening the PowerShell window and now typing kubectl version short client, and as you see that it is showing that client version 1.18.9 EKS it's showing. So we have successfully configured kubectl in our system. Now let's proceed to the next section where we will be trying to connect our newly created EKS cluster from this kubectl in local system. So far we have installed kubectl utility in our system, local system, and now we will be trying to connect to our Amazon EKS cluster from our local system. So let's go back to our EKS cluster and let's see the status. As you see that the cluster has been successfully created and it's showing active. Now from this console I can see it is active. How can you check its status from the kubectl utility we have just installed and configured in our local system? So to do that, open your PowerShell window and run this command. The command says AWS EKS, you have to specify the region. In our case, it is US East 1. Describe cluster -- name, and you have to put your cluster name, which is in our case AWS TG EKS, and -- query cluster.status. So it means that we want to check the status of the cluster. Give enter. As you see, it is giving an error, which is saying an error occurred, unrecognized client exception. When calling the describe cluster operation, the security token included in the request is invalid. Now take a minute and think that what can be the reason. Well, let me tell you that when you see the error message which is saying the security token included the request is invalid, it means that the token it is trying to use for the authentication is invalid. If you remember, in our past session we configured AWS configure. Basically we installed AWS CLI and did AWS configure, and during that AWS configure we used AWS key and secret key. It is talking about that. So as it is saying that token included in this request is invalid, let's go to IAM. So from search, type IAM, go to IAM, go to user, select the user, select security credential, and here I see that I kept the access key inactive. So I'm just making it active. After this tutorial, I will be dropping this access key. Now let's go back to our PowerShell window and give a try again. Now our access key is active. So it's showing that our status is active. Now it means that it is able to connect to the cluster and check what is the status. That's why it is showing active. Now remember one thing, where the developers I have seen make silly mistakes. User you used for creating the cluster. So I'm going back to my cluster. This is the user we used to create this cluster from this AWS console. And you have to use the access key of the same user from your AWS CLI when you are trying to connect to this cluster. If you are using different user in your AWS CLI to connect to the cluster which has been created by another user, then the procedure is different and we have to modify few more things as well. So remember the simplicity that whatever the user you have used in AWS console to create the cluster, you have to use the same user token when you are connecting from your AWS CLI. Now I have cleared the screen and again running that command to check the status of the cluster, as it is perfectly showing active. Now we have to update the kubeconfig in local system, and to do that we have to run one more command, and that is AWS EKS specify the region, update kubeconfig -- names, and add the name of your EKS cluster. Press enter and you find that added new context to this location. And now let me open this location. Just copy this part and here is the config file created. So let me open it in a notepad, and as you see that it has the API version, cluster, certificate, server, and all these things whichever is required. Type kubectl get service or SVC, and it is showing the Kubernetes cluster IP type, cluster IP 10.100.0.1, external IP port 443, age 22 minutes. So we are able to connect to our cluster from this local system where we have installed our kubectl utility, and we are able to run all the kubectl commands as well. So if you at this moment, if you just run kubectl get pods, definitely there is no pods, so you will not get anything. So no resources found in default namespace. The reason is we have only created the master node in the cluster. So if you just do for kubectl get all, you will get only one object, which is a Kubernetes service of cluster IP type. So now in the next session, we will be creating the worker nodes in Amazon EKS. So let's proceed. This is the complete reference course where you will get all the lab hands-on at one place. AWS CI/CD automation complete reference for production ready system. Yes, if you check that what you will learn, you will get lot more what you will expect. In this course, we have the lab or hands-on practice on code commit, code artifactory, ECS cluster, CI/CD using code pipeline, code deploy, complete hands-on practice based on actual production scenario, ECS rolling update, ECS blue-green using code deploy lab, and lot more. So far we have created the EKS cluster, installed kubectl in local system, connected to EKS cluster from local system, and executed few kubectl commands. Now in this session we will be creating worker nodes. Now under this cluster, if you click on networking, you will find all the VPC subnets which are being used for your cluster. Click on compute and you will find the node groups. Currently it is showing 0. Amazon EKS allows you to group number of nodes for a particular purpose. Suppose for one application you need 2 nodes. For another project, another application, you need 5 nodes. So you can group number of nodes. So under this node groups, click on add node group, give a node group name, suppose group 1, node IAM role. So it is the role which will be used by the node. So again I'm clicking on IAM role, click on role, click on EC2, search for EKS, and you will find EKS CNI policy, EKS worker node policy, and we will be using ECR, AWS ECR, which is Elastic Container Registry, and that's why we need the access for the same, the read access only. So that will be basically container registry read only. Click on next. We are not adding any tags. Review, give a name which is AWS TG worker node. Create row, and we have created this row. Let's go back to EKS. Click on this refresh icon and we have EKS worker, the new role we have created. Scroll down. We are not using any launch template, so skipping this, not adding any labels, tags. Labels we are at this moment we are not adding in the node group, but when you will be launching or creating any definition template, definitely you can add Kubernetes level in that. Click on next. Now we are going to set the compute and scaling configuration of the particular node. Now node means it is actually a system, a virtual system definitely. Now which kind of virtual system, which type, how is the configuration, and we have to set here. So the AMI type, I am keeping it as it is, which is Amazon Linux 2. Now capacity type is on demand. I'm keeping it on demand. And instance type, I'm taking it the smallest one for this demo purpose. So the smallest one, if I say that T3 micro, I'm taking the T3 micro one only. Okay, the disk size, it is saying by default 20 GB, but for this demo we are taking 5 GB only. Node group scaling configuration, minimum size, maximum size, and desired size. At this moment we are not configuring scaling, so I am keeping all this as default. So minimum will be 2 nodes, maximum 2, and desired 2. So ultimately there will be 2 nodes only. So let's click on next. Now, as I said, when I was creating the master node, that we used the VPC, the same VPC we will be using for creating the master as well as the worker nodes. So here we are selecting the subnets from the same VPC, and this same subnets has been selected automatically. Allow remote access to nodes. Now for this demo purpose, I am keeping it enabled because without the remote access enabled, I will not be able to connect to the nodes directly. But in your production environment, in your organizational network, maybe you need to restrict this remote access to nodes. Okay. Now, when I am allowing the remote access to nodes, definitely I have to select a SSH key pair where I can connect to that node. So I have selected one key pair already created. If you want to know how to create the key pair, there is a link, which is click over this link, EC2 console, open it in a new browser, and on the left hand side you will search for key pair. Click on this key pair, click on create key pair, and you will create one, give a name of the key pair, new key pair. You can select the PPK if you are using PuTTY, or PEM file if you are using OpenSH. So as I will be using PuTTY, so that's why I kept it as PPK, and click on create key pair. It will be downloaded to your system. In the prerequisite section of this course, I have provided how to create the key pair and how to configure your PuTTY to connect to those nodes. So going back to EKS again, click on next. This is the review and create section. You just give a review and click on create. And you see that the status is creating. So the node group has started created. Now let's go back to our PowerShell window where we were checking that what are the objects created in Kubernetes. So now let's see kubectl get nodes watch. Sorry, there was a typo. The node group is still being created. That's why it is taking time. And it is also finding the nodes being created as I have added this watch. So whenever any node is created, it will show it here. As you see, these nodes are being created. The status is showing not ready. And if I refresh it over here, it's still showing creating. And now it is showing ready, which is actually there are two nodes have been created. One node is 3179, another is 3140. So now if I just do a kubectl get nodes, sorry, typo, kubectl get nodes, it shows me two nodes, which is 172 31 40 253, 172 31 79 10. These are the two nodes have been created under this cluster and inside the node group, group 1. So this is how we have created Amazon EKS cluster, master node, and a node group of 2 nodes in a same VPC in associated subnets. Now let's proceed to the next section. This is the complete reference course where you will get all the lab hands-on at one place. AWS CI/CD automation complete reference for production ready system. Yes, if you check that what you will learn, you will get lot more what you will expect. In this course, we have the lab or hands-on practice on code commit, code artifactory, ECS cluster, CI/CD using code pipeline, code deploy, complete hands-on practice based on actual production scenario, ECS rolling update, ECS blue-green using code deploy lab, and lot more.